Something strange is happening across the vast, unbroken expanse of the Pacific Ocean. From high above, where satellites quietly orbit, endlessly watching the world below, something new has begun to shimmer on the ocean's surface. At first, it was subtle. A glimmer here, a flash there. Isolated incidents dismissed as camera anomalies or brief tricks of the light. But then, the glimmers became patterns. The flashes became persistent. And soon, across wide swaths of open water, the Pacific began to reflect light in a way no one had seen before. It was almost surreal, like the ocean had turned to polished glass. A mirror, stretching to the horizon, catching sunlight at impossible angles. The kind of sight you'd expect in a dream or a painting, not in real life. This wasn't just a one-time event or a fleeting illusion. Reports started trickling in, from pilots flying over the Pacific, from commercial vessels, even from the International Space Station. All described the same thing: strange, brilliant reflections dancing across the water, bending and bouncing light as if the ocean had become a giant, undulating mirror. These weren't the usual sun glints caused by waves or atmospheric haze. They were something different. Something more precise. More concentrated. And above all, more mysterious. Scientists who spend their careers studying Earth's oceans, clouds, and atmospheric behaviors found themselves poring over satellite imagery, running spectral analyses, and asking a question they weren't prepared for: why is the ocean reflecting light like this? Now let's take a step back and think about the sheer scale of the Pacific. It's the largest and deepest ocean on Earth, covering more area than all the continents combined. It breathes with the tides, stirs with unseen currents, and holds secrets we still haven't uncovered, even in the modern age of advanced sensors and global monitoring networks. For something this unusual to happen out there, in such an enormous and carefully studied region, and for it to leave experts baffled, well, that's not something that happens every day. It's easy to forget just how much of our world is covered in water, and how much of that water remains unexplored. What lies beneath, and what surfaces to the top, often escapes our understanding. But now, something is showing itself, not below the waves, but on top of them. And the timing is uncanny. We live in an age of information, where satellites can measure the chlorophyll content of ocean water or detect temperature shifts within a fraction of a degree. We have weather models that can predict storms weeks in advance and sensors that can track plankton blooms from space. Yet despite all this data, all this observation, we've never recorded the Pacific behaving this way before. It's not just an optical illusion, not just a rare alignment of sunlight and atmosphere. Whatever is happening is physical, measurable, real. And it's leaving experts scratching their heads, unsure what to make of a phenomenon that, by all accounts, shouldn't be possible at this scale. And here's the thing: when scientists are baffled, it's not because they've seen something minor. It's because the rules they've come to rely on, the systems they understand so well, are no longer matching the outcomes they're seeing. For years, oceanographers have tracked light reflectivity on the seas. They understand the factors: wave motion, surface tension, wind speed, solar angle, cloud cover. There are algorithms for it. Predictive models. Entire systems built around understanding how light interacts with water. And yet, none of those models predicted this. None of them explain why certain sections of the Pacific have become eerily reflective, almost like someone polished the surface with glass cleaner and turned the brightness up to maximum. It doesn't fit the data. And it doesn't fit the past. People might wonder, is this really that unusual? Isn't the ocean always shimmering? Isn't that just what water does in the sun? But anyone who's studied light knows there's a difference between glimmer and mirror. A typical ocean surface is chaotic. It breaks up sunlight, diffuses it in every direction. But this is structured, focused. It's like the Pacific is trying to send a message. A flashing signal, bouncing light toward the sky in ways nature has rarely, if ever, allowed. And perhaps the most unnerving part? The effect is growing. It started as a few isolated incidents. But now, it's happening more frequently. Over larger areas. With greater intensity. Whatever's causing the Pacific to turn into a reflective sheet, it's not going away quietly. It's ramping up. And still, no one knows why. Some scientists, grasping for an explanation, have started looking not into the sky, but into the surface behavior of the ocean itself. Could this strange mirror-like effect be the result of a natural shift in how calm and still certain parts of the Pacific have become? On most days, the ocean is a restless body. It moves with purpose, pulled by tides, stirred by winds, and constantly rippling under the weight of even the smallest breeze. But recently, observers have noticed something peculiar. Entire stretches of the Pacific have been unusually still. Strangely smooth. Almost glassy. Like the usual movements that keep the surface in constant, chaotic motion had slowed to a crawl, giving way to an eerie calmness. Now, to most of us, that might not sound like a big deal. Calm water, rough water, it all just looks like ocean. But for scientists who study surface tension and wave activity, this kind of widespread stillness is anything but normal. Oceanographers track wind patterns, barometric pressure, sea surface temperature, and a dozen other factors to determine how the ocean should behave at any given moment. And based on those models, the level of calm they're now witnessing doesn't line up. It's too smooth, too consistent, and far too spread out. And when the ocean becomes calm, truly calm over a massive area, it changes how light behaves on its surface. Imagine looking at a lake early in the morning, before the wind picks up. You've probably seen how it can reflect the sky like a perfect mirror. The trees, the clouds, even birds flying overhead, they all appear in that glassy surface. Now scale that up. Imagine that effect not just in a quiet lake, but across hundreds of miles of open ocean. That's what some researchers believe might be happening in the Pacific. A kind of rare, widespread stillness that's turning the sea into a colossal reflector. But then the question becomes, why is the ocean so calm in the first place? Some experts are pointing to subtle atmospheric shifts, a drop in regional wind speeds, changes in pressure systems over the Pacific, even long-term climate patterns that might be settling certain areas into temporary lulls. These changes don't seem dramatic enough on their own, but taken together, they might be just enough to flatten the water's surface. And with a smoother surface comes a more precise reflection of light, something our satellites and aircraft are now picking up in ways we've never recorded before. But the idea of calm waters causing this effect, while possible, leaves people unsettled. Because for this explanation to hold, we need to believe that nature itself has spontaneously hit the pause button over large parts of the ocean. That the winds which have stirred these waters for centuries have suddenly backed off. That the endless churning of waves has slowed, not just here and there, but across an entire region. And while scientists can track some of these wind patterns, the scale and persistence of this calm still doesn't make much sense. Weather systems shift all the time, sure. But not like this. Not with this level of consistency. And not without other ripple effects showing up in the data. And so, the theory, while technically plausible, doesn't give us the full picture. It answers one question while raising several others. Yes, calm water reflects light better. But why now? Why here? And why is it growing? Is this just a rare natural pause in the ocean's typical behavior? Or is something else encouraging this calm? Is there an underlying factor we've missed, something that's nudging the Pacific into stillness? No one can say for sure yet. But it's this kind of speculation that keeps researchers digging, sending out more sensors, scanning more images, and looking for patterns where none yet exist. When experts first proposed that the ocean's unnerving reflectivity could be tied to an unusual calm on its surface, it wasn't just a casual guess. It came from hours of reviewing satellite images, comparing historical weather records, and studying the way sunlight interacts with different textures of water. You see, the ocean isn't just some giant bathtub that sits still when the wind dies down. It has layers of movement, currents above and below, and forces acting on it from every direction. Even when the skies are clear, and the wind is absent, the ocean typically fidgets. Swells, currents, and subtle pressure differences usually keep the surface moving just enough to scatter sunlight. That's why this sustained smoothness is so startling. It defies what we've come to expect as the ocean's normal behavior. To even suggest that natural stillness could be this widespread, scientists had to reconsider what they thought they knew about surface dynamics. Think of it this way: calm water, like you'd see in a harbor or bay, is often a local event. Maybe it's sheltered by geography, or maybe there's a brief lull in the wind. But what we're seeing here isn't confined to a quiet cove. It's showing up in open ocean, vast, uninterrupted stretches where no landmass shields the surface, where winds should have full reign. Yet the data shows otherwise. Light is bouncing back cleanly, not just in patches, but across regions. And not just for an hour or two, but for days at a time. That's not just an unusual event. That's a pattern. A shift. Something bigger. Oceanographers are also paying close attention to how small-scale weather patterns might be stacking up in strange ways. Could there be a coincidental convergence of weaker-than-average trade winds, higher-than-usual atmospheric pressure, and cooler sea surface temperatures all happening at once? On paper, it seems far-fetched. But when you combine several small anomalies, the result can sometimes be dramatic. It's like when you stack several coins one by one. They don't weigh much alone, but together they make an impact. Similarly, these seemingly minor deviations from normal behavior, winds slowing down just a little, temperatures dropping just a degree or two, could all be working together to put the surface of the Pacific in a sort of suspended animation. And if that's true, then the mirror-like effect we're seeing could be the result of a delicate, temporary balance. A rare harmony of natural forces that isn't permanent, but just stable enough to create this eerie visual phenomenon. That idea is both fascinating and unsettling. Because if this state of calm is something that's emerged out of fragile coincidence, it could also vanish just as easily. A shift in wind currents, a passing storm system, or a sudden warming trend could tip the balance back toward chaos, returning the ocean's surface to its usual restlessness. But until that happens, we're left observing a calm that feels almost intentional, like nature's taken a breath and decided to hold it. There's also been talk among some in the research community about underappreciated variables, like microcurrents and thermoclines, thin layers of rapidly changing temperature that exist beneath the surface. While invisible to the naked eye, these underwater features influence how energy moves between the ocean and the atmosphere. If certain layers of the Pacific are colder than normal, they might be suppressing turbulence at the surface. And since colder water is denser and tends to sink, it could be keeping the top layer stable, preventing the kind of rolling, reflective disrupting motion that's typically present. Again, these aren't easily observed changes. They don't show up in tourist photos or even basic satellite imagery. But when you start layering these pieces together, a picture begins to form. One where everything is just calm enough, just quiet enough, to let the light bounce back like it's hitting polished glass. Still, the sheer size of the affected area complicates things. We're not talking about a few miles of oddly bright water. We're talking about vast swaths of the Pacific where sunlight is returning with abnormal intensity. Pilots have described it as a shimmering path that stretches to the horizon. Satellite sensors that usually register dark, scattered light across the ocean are showing sharp contrasts, as if something is flattening the chaos out of the water's surface. And perhaps most striking of all, this isn't a one-off. It's recurring. It's sustained. And no one is quite sure why. Which raises an important point. If this calm is the result of a natural process, why haven't we seen this before? The Pacific has gone through countless atmospheric shifts, seasonal cycles, and even long-term climate patterns, but nothing in recorded history shows a reflective behavior quite like this. Could we be witnessing a once-in-a-generation event? Or is it possible that the ocean has entered a new phase entirely, one where the rules have subtly changed and we're only just starting to notice? That's the real mystery here. Not just the reflection itself, but the possibility that something has fundamentally shifted in the ocean's behavior. And if calm waters are the beginning of that change, what comes next? The questions are endless. The answers, for now, are still shimmering somewhere on the surface. Bright, puzzling, and just out of reach. While the stillness of the water remains a strong contender for why the Pacific has begun to glint like polished chrome, there's another suspect quietly gaining attention in scientific circles: the sky above. More specifically, the unusual clarity and composition of the atmosphere. Because when it comes to how sunlight behaves, the story doesn't begin and end at the ocean's surface. It starts way up high, miles above sea level, where the air itself plays a powerful, often overlooked role in how light travels, scatters, and reflects. See, under normal conditions, the atmosphere is filled with all kinds of microscopic things that bend and break up sunlight. Dust, water vapor, aerosols, smog, these particles scatter sunlight in all directions. It's the reason the sky appears blue during the day and red at sunset. It's also why the sunlight that reaches the ocean is usually somewhat softened, diffused, no longer coming in a clean, direct beam. It hits the water at different angles, with varying degrees of intensity, and usually, that's enough to keep things looking pretty ordinary. But lately, scientists have been noticing something strange in the skies over the Pacific. Air quality readings from several remote observation stations show a drop in atmospheric particulates. Essentially, the air has been cleaner, drier, and more transparent than usual. At first, this didn't raise many eyebrows. After all, a temporary shift in air clarity isn't unheard of, especially in less industrialized zones of the world. But then, the light readings started behaving oddly. Solar irradiance, essentially, the measure of sunlight intensity, has been spiking in specific Pacific regions. And not just in isolated blips. These spikes have lasted for days at a time, aligning almost perfectly with the regions where the ocean is reflecting the most light. This kind of alignment is too precise to ignore. Because when sunlight travels through a cleaner, drier atmosphere, it retains more of its original intensity. There's less scatter, fewer particles to weaken or deflect it, and so the beam that hits the ocean arrives stronger, more focused, almost like a spotlight. And when that kind of focused light hits an unusually calm body of water, the reflection can be blinding, crisp, unfiltered. The kind of image that satellites can't ignore, that pilots can't look away from. It's the perfect recipe for a mirror-like surface. Now, the big question becomes, why is the atmosphere suddenly so clean in the first place? That's where things get more speculative, and also more interesting. Some meteorologists have proposed that upper atmosphere wind patterns have temporarily shifted, pushing airborne particles and pollutants away from the Pacific Basin. These high-altitude winds, known as jet streams, operate like invisible conveyor belts. If one of them has dipped lower or changed course, it could be sweeping debris out of the region, leaving behind an unusually pure corridor of air. It's not something we normally notice from the ground. Skies might look the same to the naked eye, but satellite sensors and specialized instruments can detect these changes. Others are pointing to volcanic activity, oddly enough, not eruptions, but the lack of them. Volcanic ash plays a surprisingly big role in atmospheric makeup. When volcanoes go quiet for long periods, there's less ash and sulfur dioxide entering the upper layers of the atmosphere, which in turn reduces the hazy, diffuse effect sunlight usually has as it filters through. So if we're in a lull, a quiet window with few eruptions globally, it could be contributing to this rare clarity. And that clarity, in combination with the Pacific's other strange behavior, may be helping the ocean reflect sunlight like never before. But perhaps what's most intriguing is that none of this feels loud or obvious. These changes in the air aren't the kind that make headlines. They don't cause extreme weather, or signal danger on their own. They're quiet shifts, subtle tweaks in the balance of gases, particles, and humidity levels that we rarely pay attention to. And yet, it might be these very subtleties that are setting the stage for something that looks, from space, like a glowing mystery unfolding on the sea. The pieces all seem to fit a little too well. Calmer than usual waters below. Cleaner than usual air above. A sun position just right in the sky. None of these factors alone might cause a spectacle, but layered together, they become something much larger. They create a canvas for reflection, literally and figuratively, where the ordinary becomes extraordinary simply because everything fell into place. And that's part of what makes this so eerie. If the sky is playing a role in this strange transformation, then we're witnessing a kind of atmospheric precision that doesn't happen often. It's a reminder that the world around us is always interacting in quiet, hidden ways. The ocean and the sky, though miles apart, are in constant conversation. And every now and then, that conversation results in something beautiful and deeply puzzling. What's especially fascinating about this whole atmospheric angle is how easily it flies under the radar. When we think of environmental changes that make a visual impact, things that would cause the ocean to shimmer like a polished sheet of glass, we imagine storms, heat waves, maybe even underwater quakes. But rarely do we consider how invisible changes in the air, the stuff we breathe every second of every day, can play a starring role in how the world looks. Now, think about this. Sunlight is powerful. We don't really stop to think about how precise it has to be to cast a clear shadow, to light up a room just right, or to make the sky turn fiery orange during sunset. The way light filters through the atmosphere is a delicate process. It gets bent, bounced, absorbed, or scattered depending on what it runs into. Normally, that means some of the light is lost by the time it hits the ground, or the ocean. But in recent months, something unusual is happening over the Pacific. The light isn't getting broken up as much. It's arriving in near-perfect condition, almost like someone wiped the smudges off a camera lens. This is where it gets more interesting. Meteorologists studying this have been collecting data on humidity levels, wind speeds at high altitudes, and even the presence of rare atmospheric chemicals like ozone and methane. All of these components influence how the sun's rays behave. What they've found is a subtle but persistent anomaly. Air masses over the Pacific are not only clearer, they're more stable. That is, they're not being stirred up or jostled by turbulence as much. These calmer atmospheric layers allow light to pass through without distortion. Imagine a calm, glass window versus a frosted one. The clearer the glass, the more direct and intense the light. The atmosphere, in a similar way, is acting more like that crystal clear window right now. And here's another piece to the puzzle that most people wouldn't think twice about: solar angles. During certain times of year, the sun's position in the sky lines up in just the right way over the Pacific. This isn't an everyday thing, it's based on Earth's tilt, orbit, and even subtle shifts caused by seasonal transitions. When these solar angles are just right, sunlight travels a shorter path through the atmosphere before hitting the surface. That means fewer chances for scattering, and a much purer beam of light making contact with the ocean. So imagine that. You've got a region of Earth where the atmosphere is unusually clean and calm. You've got a period where solar angles are nearly ideal. And then, that light, clean, bright, uninterrupted, hits a stretch of water that's also calm, undisturbed, and just slightly tilted to reflect the light in the direction of satellites and passing aircraft. The result? A massive glint. Not just a sparkle or a shimmer, but a full-on mirror effect that stretches for miles. To someone high above, it looks unreal, almost artificial. But it's all natural. And it's likely temporary, an atmospheric fluke that just happened to play out perfectly. There's also the question of how widespread this atmospheric shift really is. Some researchers believe it may extend far beyond the Pacific. That what's being observed over the ocean is just the most visible part of a larger trend. Satellite instruments have started picking up similar light behavior over other large bodies of water, though not nearly as intense. This raises the possibility that we're in the midst of a subtle, global atmospheric transformation. Not enough to affect weather in any dramatic way. Not enough to trigger a crisis. But just enough to tilt the conditions, for a short while, into a kind of perfect harmony. It's like the Earth took a breath and everything stilled, just long enough for the sky and sea to sync up in a rare, silent agreement. Of course, no one's pressing a panic button over this, not yet anyway. Most scientists are treating it as a phenomenon worth watching, not fearing. But even in its calmness, this atmospheric shift is mysterious. It feels like the kind of thing we'll only understand in hindsight, once more data rolls in. Until then, we're left watching the Pacific shine back at us, as if holding up a mirror to the sky itself. While some experts point toward atmospheric clarity as the culprit behind these massive light reflections over the Pacific, Others are turning their eyes downward, right to the surface of the ocean itself. More specifically, they're looking at what's resting on top of the water. Because if there's one thing the ocean isn't, it's uniform. Sure, from a distance it may seem like a single endless blue canvas, but the top layer of the sea, the place where air and water meet, is actually teeming with complexity. And lately, that layer has been acting differently. What scientists are beginning to suspect is that a growing number of surface slicks and biofilms could be playing a pivotal role in transforming these oceanic regions into natural mirrors. These slicks aren't just random occurrences. They're physical layers, sometimes just micrometers thick, that can stretch for miles. At first glance, they don't seem like much, barely noticeable streaks or patches across the water, often invisible unless lit just right by the sun. But when conditions are ideal, these slicks become highly reflective. And when spread out across large sections of ocean, their impact becomes anything but subtle. So where are these slicks coming from? Some are entirely natural. Oceanic biofilms can be produced by algae, bacteria, and other microscopic organisms that live at the very edge of water and air. These organisms release oily substances, essentially microscopic byproducts of their life processes, that float to the top and form an ultra-thin film. Now, under normal conditions, these films are short-lived. Wind, waves, and the natural churn of the sea break them apart before they can accumulate. But lately, oceanographers have noticed something peculiar. The slicks aren't just forming more frequently, they're sticking around longer, and they're forming in much larger patches. One possible reason for this has to do with temperature. The surface of the Pacific has been experiencing unusual warming trends over the past year. Not drastic enough to sound global climate alarms, but just warm enough to affect how organic matter behaves. Warmer water encourages microbial growth. That means more plankton, more bacteria, more biological activity, all of which translates to more biofilm production. When these compounds build up, they don't just float, they spread. And when the wind is calm, when the water is still, these biological slicks can stretch like pancake batter across a griddle. Flat, smooth, and ready to reflect. Add to that the growing concern about human-made pollutants, especially those of a chemical or petroleum nature. Shipping lanes crisscross the Pacific daily, and even with modern regulations, oil residues and chemical discharges still find their way into the water. While many of these traces are minuscule, when spread across vast areas they can form their own kind of reflective slick. These are more persistent than organic films and much harder to break up. And under the right lighting conditions, they can reflect sunlight with almost uncanny intensity. Now imagine this. You've got both natural and artificial slicks growing in size and number. You've got warmer than usual sea surface temperatures helping them spread faster and stick around longer. Then you have stretches of calm weather, no strong winds, no major swells. The surface of the Pacific becomes eerily smooth, like a massive glass plate stretching from horizon to horizon. And then the sun rises, casting its rays across this glossy canvas. What bounces back is not the familiar glitter or scattered shimmer of moving water, it's a solid, blinding, silvery glow. A mirror in motion. But here's where it gets even stranger. Satellites that monitor sea surface reflectivity have picked up unusual readings that match perfectly with regions where these surface slicks are suspected to be forming. In several areas, the reflective signature mimics what you'd expect from highly polished surfaces: metal, ice, even glass. That's not normal. Oceans scatter light because they're constantly in motion. But this is something else. Some satellites were even briefly blinded by the intensity of the glare, triggering errors in remote sensing equipment. That kind of reflectivity from open water simply shouldn't happen. And while no one's come out with definitive proof yet, more and more oceanographic teams are now being dispatched to these regions for hands-on testing. Some are collecting surface samples to analyze the chemical makeup of the films. Others are using drones and infrared sensors to get clearer readings of how the light is being reflected. Early tests are hinting at an unusual blend of natural biofilms mixed with trace hydrocarbons, possibly from cargo ships or even long-dispersed oil slicks. In combination, these form a kind of hybrid film, thicker than what's typical, and far more reflective than expected. But even beyond the science, there's something viscerally unsettling about this idea. The thought that the ocean, this wild, free, unpredictable force of nature, is slowly turning smooth, still, and reflective. Like it's wearing a mask. Like it's hiding something just beneath the surface. People on ships have described it as eerie. Some claim it looks like they're sailing through a sheet of silver, as if the ocean itself has stopped to stare back at them. Others say it feels like moving through a dream, or worse, a warning. It also raises deeper questions about the health of the ocean. If these slicks are forming more often, and with greater intensity, what does that mean for marine ecosystems? Surface films block the transfer of oxygen between air and water. That could put stress on plankton, fish larvae, and other sea creatures that rely on the upper layers of the ocean. And if they're made partly of pollutants, then what's being hidden under that shine might not be beautiful at all. It could be a growing sign of imbalance, something that looks stunning from afar but spells trouble up close. Still, we have to acknowledge how little we actually know. The ocean has always held secrets, and for all our satellites and sensors, we're still mostly guessing. This mirror-like phenomenon might be temporary, a result of rare and coincidental conditions. Or it could be the first visible sign of something more enduring, a shift in how the sea interacts with the air, how biology mingles with chemistry, how light plays across the planet's largest surface. For now, though, the Pacific glows. Quiet, strange, and reflective. And we continue to watch it, fascinated and slightly unsure, waiting for the next clue. There's a growing theory, quietly whispered among a handful of marine researchers and geophysicists, that suggests something else entirely might be at play here, something happening far beneath the waves. Not an atmospheric anomaly, not a layer of surface chemicals or biological goo, but a subtle, ongoing shift in the seafloor itself. Specifically, the idea that massive underwater geothermal activity, possibly from an awakening fault line or a vast network of hydrothermal vents, could be subtly altering the behavior of the water above in ways we've never fully documented before. Now, on the surface, this might not sound like the sort of thing that would create mirror-like reflections. We typically associate seafloor activity with earthquakes, volcanic eruptions, or at the very least, clouds of heated water bubbling up into the cold ocean. But this theory proposes something more nuanced. What if this geothermal surge is heating vast sections of the ocean from below? Not enough to boil or erupt, but just enough to gently change the density, temperature, and even clarity of the water above it. Water, as simple as it seems, is an incredibly complex medium. Tiny shifts in its temperature or composition can have cascading effects. And according to some early, unconfirmed sonar readings, certain parts of the Pacific, particularly those now reporting high reflectivity, may be experiencing temperature anomalies just a few degrees above the surrounding areas. Not enough to trigger panic or suggest volcanic activity, but still enough to raise eyebrows. Here's where it gets interesting. If you heat a wide swath of ocean from beneath, the warmed water begins to rise. But depending on the conditions, it may not rise in violent bubbles. It can form these strange, stratified layers. Warmer water sits above the cold, forming what's called a thermocline, and in some unique scenarios, this thermocline can act like a lens. A natural magnifying glass, almost. Some simulations suggest that when light hits a sharply defined thermocline, especially one that's unusually flat and extensive, it can reflect with eerie precision, bouncing light back into the atmosphere like a signal mirror held at just the right angle. Now pair that with the right time of day, clear skies, and a calm sea surface, and suddenly you've got a section of ocean that gleams like polished metal. But it's not the surface itself doing all the work. It's the hidden layers beneath, shaped by subtle warmth seeping up from the planet's molten heart. Some speculative models even suggest that these underwater zones could stretch for dozens, possibly hundreds, of miles. That kind of hidden heating could subtly iron out turbulence in the upper layers, smoothing the water's surface, making it even more reflective. And because this geothermal energy isn't consistent or evenly spread, we might only see these reflective anomalies when conditions align perfectly. which would explain why satellites don't see them every day, why they seem to come and go like phantom signals. And then there's the matter of minerals. Hydrothermal vents and undersea rift zones don't just release heat. They also belch out a cocktail of minerals, silicates, sulfides, metals. If these rise in tiny particulate form and settle near the surface, they might create a very fine layer of suspended particles. Not enough to cloud the water or change its color noticeably, but just enough to catch and redirect light at certain angles. Think of it like a glitter dust effect, spread invisibly across miles of sea. You wouldn't see it standing on a boat. But viewed from space, under the right conditions, it might look like a silver sheen stretching across the ocean like a brushed metal ribbon. Of course, no one's proven this. It's still deep in the realm of theory. There are only scattered sonar reports, some patchy thermal imaging, and a few speculative papers floating through academic channels. But that hasn't stopped a growing number of ocean researchers from pushing for more funding, more deep-sea expeditions, and more satellite passes over the areas of interest. Some even believe there may be entirely new geothermal structures forming, structures we haven't mapped yet, because they're just now beginning to stir. What would it mean if this were true? It would suggest that the Earth is changing in subtle, quiet ways we haven't yet caught up to. That something deep below the Pacific is awakening, not with fire and fury, but with warmth and a kind of strange, underwater whisper. A reminder that the planet is still very much alive under our feet, and that the ocean, for all its vastness, is not immune to change from below. And there's something deeply poetic about that. The idea that what we're seeing now, this ocean turned to glass, this mirror of light stretching across the Pacific, might not be a warning or a malfunction or a quirk of pollution. It might be the Earth itself, quietly shifting gears, breathing heat upward through its bones. Not enough to shake us, just enough to shine. Let's imagine for a moment that these light-reflective patches over the Pacific become a recurring part of our planet's natural landscape. That they're not just a rare event, but a growing trend. It raises a pressing question: how does a massive, mirror-like ocean start to affect the delicate balance of our planet's climate? One of the first potential effects, arguably the most far-reaching, concerns global temperature patterns and atmospheric circulation. See, the ocean isn't just a massive body of water, it's a giant, living engine that helps regulate the Earth's climate. It absorbs sunlight, stores heat, and slowly releases it back into the atmosphere, helping to maintain balance across seasons and regions. But what happens if the ocean starts to reflect more sunlight than it absorbs? This mirror-like quality could, in theory, reduce the ocean's ability to take in solar energy. Normally, darker surfaces, like deep blue ocean water, absorb a lot of sunlight. But a brighter, shinier surface reflects it back into space. That's the same principle behind why people wear light-colored clothes in summer, to stay cooler. So if these patches of the ocean are reflecting more light, they're essentially cooling themselves down, at least on the surface. But here's where it gets complicated. A cooler surface might seem harmless, even beneficial in a warming world, but it's more about disruption than simple cooling. When surface water gets cooler than normal, it can begin to interfere with the natural temperature layering in the ocean. These layers are crucial because they drive massive currents like the Pacific Decadal Oscillation and the El Niño, Southern Oscillation. A disruption in those systems can cascade into real consequences, shifting rainfall patterns, disrupting monsoons, altering wind flows. Countries that rely on predictable seasonal rains, like those in Southeast Asia, South America, or parts of Africa, might suddenly find themselves facing droughts, floods, or freak weather that devastates crops and communities. And it doesn't stop there. These same reflective areas could influence the formation of cloud cover. Clouds form in part due to the interaction of ocean warmth and atmospheric moisture. If wide areas of the Pacific suddenly start bouncing sunlight back instead of heating up, you could see major shifts in cloud patterns. That might sound like a small thing, but clouds are one of the biggest unknowns in climate science. They affect everything from how much sunlight reaches the ground to where and when it rains. A shift in cloud cover could lead to unexpected cooling in one part of the world and unexpected warming in another, throwing an already delicate global climate into new territory. Now let's take a different angle, something a little more human-centered. Another area that could see major impact is global shipping and navigation, particularly in the realm of satellite and aerial systems. At first glance, it seems unrelated. What do shiny oceans have to do with cargo ships and planes? But the truth is, modern navigation systems are deeply reliant on accurate satellite imaging and sensor data. Many of these satellites use visible light, infrared, or other imaging methods to detect patterns in the ocean's surface, waves, currents, thermal gradients, and even algae blooms. These tools help inform pilots, route cargo ships efficiently, and even aid in search and rescue operations. Now throw in vast swaths of ocean that are suddenly reflecting light like polished glass. Some of the initial satellite data has already shown signs of being skewed or overexposed when trying to capture these reflective zones. In layman's terms, the satellites are getting blinded. This could be like trying to take a photo with the sun in the background. Everything gets washed out, detail disappears, and the image is useless. If these reflective zones expand or become more intense, we could see growing blind spots in our satellite coverage. For the world's cargo fleets, that might mean relying more on older, less precise systems. Travel times could increase. Routes might become riskier, especially in remote areas of the ocean. For air traffic over the Pacific, particularly long-haul flights, unexpected anomalies could make weather forecasting less reliable, increasing turbulence or rerouting flights unnecessarily. And then there's military navigation. Many of the world's navies rely on extremely sensitive optical and thermal sensors to track ships, submarines, and aircraft. If those sensors are suddenly overwhelmed by large reflective surfaces, they might lose their effectiveness in key areas. That could lead to increased tensions in already contested regions of the Pacific. Misread signals, false alarms, mistaken identities. In the tightly wound world of global defense, a little uncertainty goes a long way. So when we look out at this gleaming stretch of sea, it's not just a marvel or a mystery. It's a potential harbinger. A change in the way our planet handles heat. A shift in how we see and move across the water. It might seem like a distant issue, an oddity for scientists and satellites to figure out. But if it persists, if it grows, it could start touching every part of human life. From the price of rice in Thailand to the path of a typhoon in the Philippines. From a cargo shipment delayed in the Pacific to unexpected snowstorms on the American West Coast. And perhaps the strangest part of all? It began without sound, without warning. Just a shimmer on the surface. A glint of light where there used to be nothing but deep, endless blue. Now that we've explored the possible causes and immediate effects of this strange, reflective phenomenon over the Pacific, it's time to shift our focus. If these light reflections become a persistent feature of our planet, what might this truly mean for humanity on a much wider scale? How could this seemingly simple shift in the ocean's surface alter the course of human progress, cultures, economies, and even our very relationship with the planet? Let's take a step back and think big. When we imagine a phenomenon like this, it's easy to focus on the technical and scientific implications. We might think of the waves of change in weather patterns, or the navigational chaos it could create. But what about the deeper, existential shifts? What does this mirrored ocean, which reflects more light than ever before, say about the broader trajectory of humanity? One of the most profound effects this ocean anomaly could have on humanity would be a deep reckoning with our environmental relationship. It would serve as a stark reminder of how vulnerable we are to the forces of nature, no matter how distant or inconspicuous they may seem at first. The ocean, our planet's largest ecosystem, has always been a stabilizing force. For millennia, it's absorbed carbon, regulated temperatures, and supported life in ways that we largely take for granted. But if something as simple as a reflection on its surface can have such widespread consequences, we might begin to ask ourselves, how much control do we really have over the natural world? And more importantly, how much longer will we be able to take this control for granted? The mystery of the ocean becoming a giant mirror might feel like a cosmic trick, an uninvited anomaly that we have no control over. Yet it may become the catalyst for a massive shift in the way we think about the environment. Suddenly, the ocean isn't just a vast, unchanging body of water, it's something that can change at the drop of a hat. It's as if the sea itself has decided to fight back against the pressures humanity has placed on it. For years, we've heard about the effects of climate change, from warming temperatures to rising sea levels. Now, this inexplicable ocean shift could serve as an unsettling manifestation of nature's power, reminding us how little we truly understand and control. On a broader scale, this phenomenon could spark a resurgence in global environmental awareness, pushing governments, industries, and individuals to rethink our consumption habits, waste management, and attitudes toward the planet. We might see a rapid push for greater sustainability, a reconsideration of how industries pollute the ocean, and an urgency to find new, cleaner technologies. It would be a massive wake-up call for the entire world, an unexpected reminder that we are mere stewards of this planet, not its masters. When considering the wider implications of a reflective ocean phenomenon, we cannot ignore the potential geopolitical and economic consequences that could arise. The changes we've talked about, shifting weather patterns, unpredictable ocean currents, altered shipping routes, would create ripples far beyond the scientific community. In fact, they could send shockwaves through economies, industries, and political landscapes. The most immediate and obvious consequences would be felt in industries that rely heavily on predictable weather patterns and trade routes. For instance, global shipping is the lifeblood of the international economy. With the ocean suddenly behaving unpredictably, even minor changes to shipping routes could cause a major disruption in trade. Think about it. If vital ocean currents are disrupted, if certain regions of the ocean experience unexpected cooling or warming, or if ports become less reliable due to unpredictable weather, it could throw a wrench into the complex global supply chain. Food, energy, electronics, and all sorts of other goods depend on smooth, uninterrupted movement across the seas. The cost of transporting goods could rise dramatically, and the reliability of supply chains would be called into question. Countries that depend on shipping routes to maintain their economic prosperity, like those in Southeast Asia, North America, or Europe, might suddenly find themselves facing a unique crisis. International relations could be strained as nations vie for control over strategic shipping lanes or scramble to adapt to new, less predictable conditions. The countries most affected by these changes might need to develop new trade agreements, invest in new infrastructure, and rely more heavily on air or land routes, both of which could be significantly more costly. In short, economies that rely on the oceans could feel the brunt of this mysterious phenomenon. Furthermore, the agricultural sector might also face major shifts. The ripples in weather patterns we talked about earlier could lead to unpredictable growing seasons for crops. Areas that once thrived due to consistent rainfall patterns might suddenly face droughts, while other regions could see flooding or unexpected frost. For countries that rely heavily on agriculture for both local sustenance and global exports, this could trigger food shortages, price hikes, and even political unrest. If these changes become prolonged, the question might not just be about how to feed the world, but who gets to control food distribution and how we manage those resources. Countries that are already facing food insecurity could find their situation dramatically worsened. On the political stage, the reflection of light over the Pacific could also become a symbol for broader global challenges. While the event itself is centered on the Pacific Ocean, it has the potential to affect every part of the globe. What if this phenomenon becomes a symbol of the broader struggle against the unknown forces of nature and the vulnerability of humankind? Governments might be pressured to take stronger action on environmental issues, leading to new, more ambitious international treaties on climate change, resource usage, and conservation. This could bring about a new era of global cooperation, or, conversely, it could ignite conflicts between nations as they jockey for control of resources or blame each other for contributing to the anomaly in the first place. In a more speculative sense, the ocean's mirror-like transformation might even bring people together in a new way. The shared awe and confusion over the event could spark a kind of collective human consciousness, an acknowledgement that we are all connected by something much bigger than ourselves. From a human perspective, the mirrored ocean could become a metaphor for reflection, not just of light, but of our way of life. It might challenge us to look inward as a species, to consider our impact on the planet, and to strive for greater unity in solving the global problems we've created. In short, the potential effects of a giant mirrored ocean stretch far beyond the immediate scientific curiosity or mystery. They could radically reshape how we see the world, both in terms of our environmental stewardship and our interactions with each other. What began as a strange and eerie phenomenon over the Pacific could eventually influence the course of human civilization in ways we cannot yet predict, nudging humanity toward a new chapter of adaptation, cooperation, and perhaps profound change. In summary, the mysterious light reflections over the Pacific Ocean present a phenomenon that, while baffling, has the potential to spark profound changes in both our scientific understanding and our broader societal dynamics. Whether driven by natural or speculative causes, the event could serve as a stark reminder of our vulnerability to nature's unpredictability. Beyond its scientific implications, this mirrored ocean might prompt a global reckoning with how we interact with our environment, as well as have lasting political and economic consequences. From shifting trade routes to a renewed focus on environmental sustainability, the ripples of this strange event could reshape the world as we know it. As humanity faces these challenges, it may also foster deeper cooperation, reflection, and ultimately, a more unified approach to protecting our planet and securing a sustainable future. If you've been fascinated by this bizarre phenomenon and the mysterious light reflections over the Pacific, make sure to like and subscribe. The world of nature holds countless mysteries, and we'll keep exploring them together. Stay curious, stay tuned, and thanks for being part of the journey.